Straddling checkboard. The straddling checkerboard is another method of fractionating text, unlike in the polybius square, where every character is represented by a pair of digits. In the straddling checkerboard is a selection of letters, usually the most common, are represented by a single digit and the rest are change of 2 digits. I set up the straddling checkerboard so that the first row of the board has the 10 digits 0 to 9. Then the alphabetical is filled into the grid beneath this, leaving 2 blanks in the first row of the alphabet. The numbers of 2 columns label the second and the third rows of the alphabet. The standard checkerboard with the alphabet in order and the blanks at 3 and 8. The order of the alphabet within the checkerboard is the main part of the key, the other part being which 2 numbers are selected. And we can generate this order in the same way as the mixed alphabet zipper. Using a keyword, it is usual, however, to populate the first row of letters with the high-frequency letters. You should also note that since there are 30 squares in our checkerboard with 2 intentionally left blank in the top row, and 26 used for the letters, there are 2 remaining usable squares. One of these is usually filled with number as a numeric escape character, identifying that the following numerical is an actual number not part of the zipper text. The order could be used for a space, a full stop, or other function mark. Checkerboard with high-frequency letters in the top row and extra characters to fill the grid. It is really important for the mechanics of the zipper to work that the 2 numbers that are used to label the rows 3 and 4 are not given in a letter in the top row. Encryption. To encrypt a message using the straddling checkerboard, we must first come up with the checkerboard itself, using a key to generate the alphabet to put in and deciding on what will fill the extra boxes in the board. We must also choose which numbers will go down the side, and this forms part of our key. With the checkerboard generated, we find each plain text in the board. If it is in the top row of letters, it gets replaced by a single digit at the top of its column. If it is in of the other rows, we use the number labeling the row first, then the column number. As an example, we shall use the checkerboard given with the high-frequency letters in the top row. The rest of the alphabet ordered by the key praised for the king, including a space and numeric escape. And the key numbers being 1 and 7, we shall encrypt the plain text attack and don't. First, we need to generate the checkerboard as below. The checkerboard with the high-frequency letters followed by the alphabet ordered by the pair for the king includes a space and numeric escape character. With this, we will look up each letter in the plain text. The A is in the top row, so is only represented by a single digit 3. Similarly, for the next few letters, but the C is in the second row, so we need the 2 digits 16 to represent it continuing in this way we get the numbers. The individual substitution for the letters of the plain text. So our final zipper reads 32231, 61311, 3211, 73756. If we now consider a plain text with a number in it attack at 6 a.m., then we can see how the numeric escape the key works. For this plain text, we must insert a number before the 6 before encryption. Using the same checkerboard, we get substitutions below. The individual substitutions including a numeric escape character. So the final zipper text this time would be 32231, 61311, 32117, 96370. Decryption. To decrypt a zipper text using the straddling checkerboard, we must again generate the checkerboard itself first. With this generated, we look at the first digit in the zipper text. If it is one of the 2 digits down the left-hand side, then we choose this row and take the next digit to find which column to look in located the plaintext letter. If it's not one of the two letters on the far left of the checkerboard, then we locate the column with the number at the top and choose the plaintext letter in the top row in this column. For our example, we shall use the checkerboard with high frequency letters in the top row and then with the keyword decrypt number. For the rest of the alphabet, we shall use 5 and 6 as the key numbers. We shall decrypt the ciphertext. As you can see in the table, checkerboard generate for this example. We start with the first digit in the ciphertext 2, which is not one of the key numbers. So we take the plaintext letter in the top row, which is A. The next ciphertext digit is 1, which is again not a key number, so we get T. We now get 5, which is a key number, so we take the following digits as well to get 50, which is the plaintext reference for the space. So far, we have at. We get another 5, so take their fair 55, which gives us the numeric escape character. This tells us that the next digit is not a reference to checkerboard, but rather part of the plaintext itself, so our plaintext becomes at 1. If we continue to break up the ciphertext in this way, we get the table shown. A bigger checkerboard with the space for the digits. The Straddling checkerboard is very good at fractionating text, but provides an element of comprehension when compared with the polybius square. This is due to the fact that the letters in the top row and the checkerboard are represented by only a single digit. If this row is populated with the high frequency characters, then the overall length of the ciphertext will be significantly decreased compared to the polybius square, which would have 2 digits for these characters. In terms of cryptanalysis, the fact that some letters are enciphered to single digits, other are encrypted to pair of digits, means that the cryptanalysis has to work out which are single digits. By choosing the wrong ones, he can head down a very wrong path, making